friends, myself Bhise Santosh from Mahatma Gandhi College, Ahmedpur. Today we are dealing with our physics topic, which is present at an 11th standard state board syllabus, that is the sound waves. See, basically sound waves, what is actually wave? Then we study the sound. Actually, it is very much important part. After in the next standard, we are going to study with the concept that is a reflection, refraction, in optics section also. So it is very much important part combined with wave section. See, in 9th, 10th standard, we studied some basic terminologies, and from that terminology, we are carrying forward to next. See, sound waves. Basically, what is a wave? Wave is nothing but the oscillatory disturbance. See, oscillatory disturbance means what? Oscillatory disturbance produced which carries the energy from one place to another place is called as a wave. Now, this is sound wave. Now, first of all, we consider the origin of sound. Origin of sound is due to the vibration. Now, this is the vibration of particles. Vibration of particles produces sound. See, some of the examples. We study some of the examples just like that. In a musical instrument, we know that the violin is guitar. In that string. Suppose a string is attached between two ends, and this string is get plucked. When it gets plucked, it vibrates about their mean position, and it produces a sound. See, another example of sound wave, we know that is suppose when we speak. Suppose I am speaking, or when this vibration of tongue in our vocal cavity, it produces the sound, and this sound, now see the complete propagation of sound. Vibration of tongue produces sound. Now, for every word there is a different kind of vibration. See, when we pronounce 2 or 3 words, there are in that 2 or 3 words there are the different vibrations, and these due to these different vibrations carries to the air, it reaches to our eardrum. That eardrum also get vibrated. That eardrum is connected to our brain via the nerve cells, and we sense the sound, sensation of sound. Another example, suppose vibration of drum, surface of drum. When it get hammered, the surface of drum get vibrated and sound is produced. So basically, what is the origin of sound wave is vibration of particle produces sound, which is propagated through air. Basically, sound needs the medium for the propagation, and it reaches to our ear, and we feel the sensation of sound. Now, before approaching these sound waves, we must study the basic concepts such like oscillations. So, we are going to deal oscillations. See, oscillations. What is actually oscillation? See some of the examples. Suppose pendulum. Pendulum means we consider a simple ball of a small mass attached with this weightless spring. This is the simple pendulum, and this is its equilibrium or mean position. When it displays through this equilibrium position through a small angle, and when it releases from this distance, it starts oscillating, and these oscillations are like this, to and fro. So vibration or oscillation, we are defining oscillation, the motion of a particle that is a to and fro about their mean position is called as an oscillation. Now, this oscillation is very much important because just we studied that in a sound, that is a vibration of particle produces sound. So here also particle perform to and fro motion about their mean position. Another example, we can say that suppose oscillation we can define another way like that, up and down motion, just like a needle of a sewing machine. That is up down motion about their mean position. That is also an example of oscillation. This is a pendulum example, clock pendulum. These are the examples of oscillation. So these oscillations of particle. Now what happens actually? When a particle vibrated about their mean position. Now here when it is released from here, it reaches at this point. That means here it acquires its that potential energy and its kinetic energy goes on reducing. Then it has a tendency to move in downward direction. So potential energy get converted into the that is the kinetic energy. Hence this motion continuously takes place. Though there is a small amount of decrease in amplitude after a long time, and we say that it is a damped oscillation because there is no external source is connected, so to have to a constant amplitude. So this is the simple example, that is a simple pendulum. Now vibration of tuning fork also. Vibration of tuning fork. See, tuning fork. Normally tuning fork on here frequency is given on the tuning fork, and when we hammer with the help of a rubber pad, it vibrates. These prongs of tuning fork vibrate about their mean position. This is the mean position. This is the mean position, and it vibrates about their mean position frequently. Their frequency is given, no doubt. But this is also oscillation. See, the oscillation is the vibration of particle, that is a to and fro motion, up and down motion, back and forth motion, and such one set is called as a oscillation. One set, that is one set means that is a one complete. See, another we will see this. This is the mean position. See, particle moves from one point second, then like this, and that means this is the one complete oscillation, one set of oscillation, and in vibration of in waves, such a number of particles are vibrated. This is the one oscillation, and this one oscillation is because that particle have tendency to restore. That is restore their original position, or we can say that is a restoring force. Due to restoring force, it try to regain their original position here. Here also, it try to regain here, but due to its velocity, like this, the prongs are get vibrated. This is the basically these are the oscillation. One set of to and fro motion, one set of up and down, that is this called as that is nothing but oscillation. And this oscillation in which the particle performing, see, we are considering one oscillation. When particle performing number of oscillations, we have that number of oscillations. That means that is these particles are vibrated number of times. So we can determine the frequency and other things. Now these are the oscillations. Then next basic terminology we need to study here, that is called as an amplitude. See, what is amplitude? In a previous figure also, just I will draw here. I will draw the same figure. When particle moves from its mean position, this is our mean position. Mean position. And this is we can call as an extreme position. Extreme position. Now here also amplitude. We study amplitude. Next term amplitude. Amplitude. We studied in the previous standard 9 and we studied this terminology, that is the amplitude. Now see here amplitude. Amplitude means when particle displaces from its mean position, the maximum distance is said to be its amplitude. Here also we can say that this is the mean position. Particles move maximum displacement from its mean position, and it is said to be called as an amplitude. Amplitude. Every particle in a set of oscillation or in a waves, every particle vibrates with the same amplitude and same period. Let's we'll study further. That is amplitude, maximum displacement. So in most of the occasion, we may ask one question like that. The distance covered during one oscillation is. Now, distance covered during one oscillation we need to find. See, suppose we consider amplitude A. This is the maximum displacement covered by the particle, that is called as amplitude. And question asked in an examination like this, maximum distance covered during one oscillation is. Most of the students may goes wrong, that is a 2A. But see, during one set of oscillation, this is it starts from here A, second another A, that is a 2A, that is a half one, then another A, this one A. That means the total distance covered one complete oscillation is equal to total distance covered during one oscillation is 4a. Remember friends, 4a, because here the one oscillation, here also one oscillation is required like this. One oscillation. This written A, this written A. Why it regain their original? Because a particle having a restoring force. That's why it tried to regain their original position. It not going to be stopped. It continues this state, and it again same moment takes place. And if the frictional forces are negligible always, but if frictional forces are negligible, then also its amplitude goes on slowly reducing after some time, and finally the pendulum is going to be stopped or vibration going to be stopped. It is not possible that the tuning fork is hammered without external energy, it stopped completely. It is not going to. It needs external energy. We have that electric tuning force. Electric tuning force or a clock pendulum. These are the source. Source is connected at the background of clock. The source is connected in the form of our pencil cell, and due to this amplitude remains constant, and that is said to be, we can say that this is an oscillation having two types, that is a damped oscillation and undamped oscillations. Damped oscillation in which amplitude goes on reducing with respect to time, and in undamped oscillations, that is the amplitude is constant, and it constant because the external power is connected to it. So this is the difference between damping and undamping. Now here this is a very much important, because in examination it also asks like that. Suppose we know the distance, time is given, ask velocity, frequency. So for this we must consider, this is a very much important point, total distance covered during one oscillation is 4a. Now this is the amplitude. Now another term is that is called as a period. We know the period because number of times this definition occur. What is the period of wave? Period of oscillation. Now period of oscillation. Time required. The time required to complete. Time are required to complete. Time required to complete one oscillation. We may consider time required to complete one vibration also. Another definition, period, it is common definition. Time required to complete one oscillation, one vibration, one wave. And so all the definitions carry the same meaning, that is called as a period. And period, periodicity, periodic in nature, these terms we need this. That's why time required to complete one oscillation is called as a period. Now, for these are the terminologies we must study before proceeding first. There is oscillations, then period, amplitude. Now, motion of bob we studied. That is the motion of vibration of fork we also studied. Now, before approaching the wave, what happened actually? Now these are the terminology. Now we have to approach towards the wave. So vibration of a single particle we studied, which is simple harmonically. We often called as a simple harmonic motion of a particle, single particle. When particle vibrates, what happens actually? When particle vibrates about their mean position, it not only just vibrate, it also forced neighboring particle to vibrate with the same period. And that's why what happens, when particle starts vibrating, it receives, wave. We are dealing with wave. In wave, one particle, suppose a force is given, energy is provided, or for tuning fork, rubber pad is hammered. What happens? This energy received by this particle and starts vibrating about their mean position. As soon as a single particle is vibrating, it sends or it transfers energy to the neighboring particle, and due to this neighboring particle, all the particles, suppose we studied like this, all particles are in rest position. Neighboring particles also starts vibrating with the same period and same amplitude. Now amplitude, same period and same amplitude, but their state of oscillations differ. That is a one by one. State of oscillation is differ. But see, the particle vibrated, it transfers energy to the neighboring particle, and in this way, energy get transferred from one place to the another place. So the sound waves we can define oscillatory disturbance which carries the energy from one place to the another place. Now in our book also one simple word is given, that one simple word, that is in a wave motion there is a transfer of only energy takes place, not matter. That means these particles are not going to change their position, it just vibrate about their mean position. What they actually transfer, the energy is transferred to the neighboring particle, and in this way the energy is transferred from one place to the another place, and in this way energy is transmitted from one place to the another place, and this is the basically wave motion. See, wave motion. Now basically these ideas are included in our previous standards, but then also we need to recall this all. Vibration of particle, oscillation of a single particle, oscillation of number of particles, which carries energy from one place to another place, and that is called as nothing but the waves. We are dealing with the sound waves now. Now this wave motion, basically in a wave, for a wave motion, there is a simple term, the mode of transfer of energy through elastic medium, in terms of oscillation, the repeated oscillation, the wave motion, we can say that is a wave motion. Now see, this wave motion is a doubly periodic. Sometimes it asks in state board examination, and we must keep in mind that wave motion is a doubly periodic. Periodic, we know that. Periodic means motion repeats after equal interval of time. Now doubly periodic. Now the doubly periodic means here periodic in time, and another, that is a periodic in space. As a wave motion is periodic in time and periodic in space, hence it is called as a doubly periodic motion. See, consider the examples. Periodic in time means the state of motion, the form of wave repeats after equal interval of time. Form of wave repeats after equal interval of time, then the state that is called as a periodic in time. Wave motion is a periodic in time because it represents after same form of wave after equal interval. Another one, periodic in space. Periodic in time, we have lots of examples. Periodic in time, that is a period of rotation of Earth, period of rotation of minute hand, period of rotation of tip of minute hand, tip of hour hand, second hand. These are the examples of periodicity. We know that is a periodic in time. Now periodic in space also. Periodic in space, that means, see, the form of wave, again repeating the same definition. Form of wave repeated after equal distances. This is the equal time, and this is the equal distances. After equal distances, form of wave repeats. Form of wave repeats after equal interval of time, and the periodic in space, that form of wave is repeated after equal distances, and hence it is called as a periodic in time and periodic in space. So wave motion is a doubly periodic motion. So it is very much clear to you that wave motion is a periodic in space as well as periodic in time. So keep in mind that. Now we will proceed further. That is a sound wave. Now basically sound, in 9th or 10th standard we might have studied the reflection phenomena. Then a question arises that the expansion happened at the surface of sun. We can't hear that. Why? You know the answer very well. What is the answer? As we know that the space between sun and moon, there is a vacuum, and sound cannot propagate it through vacuum. That's why we say that the number of explosions, heavy explosions at the surface of sun, we can't hear at the surface of earth. So these sound waves. Now sound waves means basically we are going to take types of waves according to, suppose medium selected, according to the vibration of particle, type of waves. So type of waves according to the medium required, type of waves. Types of waves. Considering, I will continue. Considering medium required. Considering medium required. There are two types. One is called as a mechanical waves. Another one is called, this is one. Second one is called as a non-mechanical waves. Non-mechanical waves. See, these are the two types, considering what I said, that considering medium required. That means when medium required, they are said to be mechanical waves. Medium not required, these are called as non-mechanical waves, or these are also termed as in our textbook as electromagnetic waves. Electromagnetic waves. Now these are the basic types. Here, first mechanical waves. Here, medium is required. Required for propagation. For non-mechanical waves or electromagnetic waves, obviously it is that is the opposite one. That is, medium is not required. That means we must keep in our mind that through vacuum also these non-mechanical waves or electromagnetic waves it can transfer. These are non-mechanical waves, electromagnetic waves. Examples are there. For these mechanical waves, we have examples. Basically, we are familiar with sound waves. This is the example for these mechanical waves. Another one, vibration of tuning fork. Vibration of air column, these are the medium required for this vibration. Vibration of fork. Now here, for this example, non-mechanical waves, or we can say that electromagnetic waves, EM waves obviously, then we can X-rays. X-rays also there. They may see X-rays, then electromagnetic waves, these are the medium is not required for that. So see, these two are the way. Now for our syllabus, for this syllabus, mechanical, in this topic we are dealing with only mechanical waves, because sound waves which require material medium for their propagation. So these are the included in mechanical wave we are studying in this topic, and these non-mechanical waves or electromagnetic waves, for here medium is not required. Another example, light wave, light rays. For this we studied it next that is in optics section we studied this non-mechanical waves or electromagnetic waves. So mechanical waves medium is required. So one condition arises in our mind that medium is not there, then also these waves are propagated. What happens? Let's see electromagnetic waves. Electromagnetic waves, basically electromagnetic waves in which there are electric as well as magnetic fields are there. Electric and magnetic field, both are perpendicular to each other. When waves is transferred, see electromagnetic waves, and I draw electromagnetic waves for your convenience. This is a single wave. Now, this is the, suppose we say that this is the electric field. This is the direction of propagation of a wave. Now, these consist of another, that is called as a magnetic field. Now, these are the magnetic field. That means electric field and magnetic fields are perpendicular to the direction of propagation. Then how it transferred? Electric field produces magnetic field, then magnetic field produces electric field. Likewise, this wave is transferred and it's very fast. As we know, the speed, it is equal to the speed of light. So these are the non-mechanical waves we are dealing in optics section. Here we are going to study the mechanical waves where medium is required. See, basically mechanical wave medium is required. We have the that is the types of wave considering the medium. So medium, for this medium we must study what kind of medium